So this is track 3 on malware. The talk is on Dex Education, Practicing Safe Dex by Tim Strazer.
Thank you. How you guys doing? Hopefully I won't put you to sleep. I know you guys all got like a post-lunch coma going on. Apparently I need to add some more buzzwords into my abstract because it's kind of thin right now, but we'll see. So who am I? I'm Tim Strazer, as I was introduced. I work at Lookout Mobile Security. We were just a small company that likes to try and do big things. Senior security engineer. It's basically a made-up role. It just means I get to do reversing and I get to actually do some engineering. I guess I'm kind of known for doing the Android market. People email me too much about this, and it's basically because I'm the only person, or one of the few people, who's bothered spending enough time looking at the thing and wasting their life doing that. So I got some really funny stories about that. If you ever want to buy me a beer, I'll chat your ear off about it, and you'll probably hate me for it. I really enjoy reversing exotic platforms. I feel like it's very, you're almost like a pioneer. You know, you get to go out there and do things that you can't Google and find 8,000 tutorials on how to do this. I'm just a junkie for that kind of reversing and different malware. Malware is always fun because they're trying to protect their code and they're trying not to be detected and whatnot. Also, I'm different Tim because there was already a Tim on my team, so people usually just call me Diff, but you can call me whatever you want. So the agenda, it's just going to be Dex Education. What is a Dex file? All that kind of good stuff. How are attackers currently hiding and trying to break the systems used to analyze malware and legitimate applications. And then we're going to move on to the anti-analysis section, where we're basically going to try and break those tools, see why they're breaking, and how can we prevent those things from being broken in the future while we're developing these types of tools, and also how to flag easy things. We're also going to try and do breaking the toolbox, which is basically that anti-emulator stuff, anti-VM. And then we're going to release a proof of concept tool and nice little lessons learned. So what is a Dex file? A Dex file just stands for, it's a Dalvik executable. It's basically similar to a jar. You're going to have your classes bundled into a jar. But in Android, it's going to be compiled down into a Dex file. So all those classes are actually flattened down into one file. And this is packaged inside of an APK file, which is basically the same thing as a jar. So upon installation, what's going to happen is you're going to have your APK file. You're going to do something like a pm install, or you're going to get it installed from Google Play. Basically, it's going to go through a quick and fast verification to make sure you're not installing a corrupt file. Everything looks pretty decent. And then on the first runtime or boot of that application, it's going to go through a little bit more of a verification through the Dalvik verifier, which basically traverses actual code paths just to make sure that there's no real funky things going on in there. So what is the Dex file? The Dex file, it basically has its header. That's just a normal header for many other file formats. It basically points to all these other tables. It points to the data section. Then you have a specific section for each one of the other parts. You get your string, your prototype, your field, your method, your class def, and these are all basically going to be used by Android to see what class am I calling, what's the name of that class, what's the string that's represented by that. And there's this huge chunk, the data section, which all these tables above are pointing off into. And that's where all the magic happens. So how can we currently examine Dex files? So there's Boxmolly. It's a wonderful tool. It's used by a lot of other tools. APK tool, which a lot of people use for unbundling resources and whatnot and helping authors translate different things. Pirates also use this tool. There's anti-LVL, which actually uses Boxmolly. But Boxmolly is just a great tool. It basically converts straight Dalvik code into what's called a Smolly file, which is basically a Jasmine syntax, but it's an exact representation of what's actually going on. IDA Pro, it's good old-fashioned IDA Pro. Most people probably know what that is. Android Guard is a really cool tool. I don't personally use it a lot. I just stick with Boxmolly, but it's a pretty great tool for manipulating and analyzing Dex files. Dex to jar is super popular from what I hear. I see lots of presentations where people are just like, cram it in Dex to jar and use it, and I'm not personally a big fan of that, but it's a great tool. It basically converts a jar file, it converts the APK into a jar file so that you can then look at it and use your actual normal Java tools to analyze that. O&O Editor, this is a great tool. I feel like it's super unused. There's a great template out there, and basically it's a really easy way to visualize what's a Dex file, where's all these bytes going, and hopefully people will start using that after I show people how to mess around with Dex files and actually see what's going on. There's plenty of other tools out there. People are just making them, left and right. Some are popular, some aren't. I think these are the most popular tools out there. So how are attackers currently hiding? For the most part, people are just doing really simple things. The malware is sort of in its infancy. Not a lot of people are looking for the malware, so nobody's really doing anything because they don't really need to right now. You don't really have to hide things too much to get by certain systems and whatnot. One of the main things that we've seen is people are starting to shift to use reflection. It's just normal Java reflection. They're using it to call sensitive APIs and whatnot, so that basically if someone's using a static analyzer and saying, hey, is someone using send SMS? Well, let me see if send SMS is being called. I'll look in the class def structures and whatnot. But if you use reflection, then it's actually just going to be a string and you're loading that in. The other way that people have been trying to hide code is dumping things into assets, trying to append it onto what should be a good file, so that if you look at the Dex file, it's actually not going to be in there. And if you don't actually take into consideration any of the other contents of the application, then you might just miss these things. We've also seen a few different things. It's not actually hasn't been used by malware authors, but there's a nice little pirate, anti-pirate war going on where people are actually trying to break these tools so that they can just F each other over. So the first one, this is just a screenshot from IDA Pro, as most of you may have seen. And basically, this is loading in the SMS manager so that they can reflectively call send text message. So it's really simple. This is just, this is what IDA Pro shows you for Dalvik code. It's really easy to do in Java, but it actually causes a little bit of a problem because most people go, okay, well, I want to detect this. Let me just detect everything that's ever reflecting anything, which isn't really a great solution because you're going to end up with a lot of false positives. So like I said, this basically lets that attacker hide a sensitive call from being actually called as a function. You're just going to see that actual reflective function with the strings being loaded in. If they wanted to get more complex, we've seen a few people do obfuscation on these strings. So in the example I showed you, it was clear what was going on, but you might see these garbled strings and whatnot being loaded reflectively, right? Maybe XOR them right before that, and it's kind of annoying. It's really easy to detect with dynamic analysis, but it actually somewhat hinders people from doing massive static analysis. So the next thing we saw is, and this is actually from malware. This is from I believe it's fake opera, fake op, fake install. There's a million different names for the malware. We really need to standardize those. But basically there was a image file. And inside this image file, which as you can see I did the file, it's just data. So you could file type this, it's not going to come up as the right file type. But there's just something weird going on. In the blue, we see that maybe there's some weird magic bytes going on. And then we also see that there's repeating OX12 coming on, so that's probably an indication that something's XORed in there. But we also see another PK header. So this is kind of an interesting one, because if you want to be really quick and you're like, oh, I'm smart, that's a PK header, I'm just going to look at that one. And if you look at that, it ends up turning into two separate zip files. So what they did, this malware author, and this is actually from Gamex, I believe. Maybe I said that wrong, but yeah, this one is from Gamex, excuse me. So basically what happened was the guy has intertwined two zip files. And so if you XOR it, you'll get the proper executable that is going to be loaded. They're going to try and push this and install this on the phone. And that's actually going to have all the malicious code. But if you were just, you weren't being lazy, but it's been a long day, you're going to go really at it, and you're going to try and get this done as fast as possible, you might have actually extracted the one that's on the left. So that's clearly a much smaller zip file and actually doesn't contain a lot of the malicious code. You'll look at it and you know that it's trying to do something malicious, but it doesn't contain all the code. It's a really interesting tactic that this guy tried to employ. So did he mean to do this? Maybe. But I would say he definitely did this on purpose, but he could have done things maybe a little bit smarter. If any of you guys actually wrote that, come talk to me. I won't tell on you, I promise. But basically, it's really cool, but he could have maybe injected Angry Birds, so that if you just looked at this quickly, it would be a legitimate Dex file, a legitimate resource file, and then he could have hit his other one right in there. This is definitely one of the most interesting things I've seen so far. And then this is another one. This one, I'm forgetting the name of the actual malware that used this. But basically, what had happened is they made an actual valid JPEG file. You can file type it, it comes out right. And if you're in your Explorer and you're looking at the preview, this is 100% legit. It's going to pop up. It's going to show you a picture. This was actually injected into, I think, an Angry Birds file. And we could clearly tell that once you look at this, you're like, well, this is a Rovio. What's Simple Studio? I don't know what that is. But then if you start grepping through the file and looking at it, you end up seeing two specific ELF binaries that are attached at the end. And one of them, I believe, was a exploit payload, and the other was an malicious ELF file that they were trying to dump onto that system. This one was really cool because it presents a really interesting problem. The last one, we could easily just do file typing and realize that something is really wrong with this. It's going to have high file entropy because it's a zip file. But here, we're going to try and file type it. We're going to get JPEG. And if we don't look closer after that, this could go through an automated system and you're just going to say, oh, well, it was a JPEG. Who cares? Nothing really happened. So it definitely makes an interesting target. So moving on to something that malware authors haven't actually done yet, but what we have seen, and this is again that whole piracy and anti-piracy thing, we've seen some developers actually pushing applications that had what we would call a link lock section. Actually got that name from anti-LVL, which implements this into all their actual pirated applications. So anti-LVL, if you haven't heard, is basically this jar that wraps around Boxmolly, and it's basically a scripting engine. So you can say, every time I see this function, I want to hook that and feed it fake data. So people have been using that to pirate applications and whatnot, and people are getting really sick of that, so they were trying to break those tools. So if you could break Boxmolly, you could break this pirate tool. And then those guys were saying, well, okay, developers are starting to try and fight me, so I'm going to fight back. So if they can't see what I'm doing, then they can't fix their application to prevent me from doing it. And basically, they were just using a header field that wasn't actually implemented in Android yet. It's in the documentation. It basically says, this is going to be linked to a statically linked file, and there's nothing else really there. So if you just throw some junk in there and it's valid, it's somewhere in the data, nothing else uses it, you can make it whatever you want, and it just didn't break anything except for Boxmolly. So I've actually seen this used by Jay Case, a couple other developers, and like I said, Lohan Plus, who is the developer of anti-LVL. But along with a simple break comes a simple fix. This was really easy to do. Basically, the code was if something was set here, throw an exception. And the fix was log an exception. Don't throw it. Don't let your program die. So most tools were already ignoring this, but Boxmolly was actually dying directly on this. So the next one was, well, that was kind of lame. We haven't really seen anything cool. So how do we break stuff? And I've always seen these slides, and I was like, okay, I got to make one of these slides. And I was going to make awesome money, and then I was like, crap, can't, because well, we're not going to sell breakages. We're just going to try and help the community and try and get this stuff fixed anyway. So as I had said before, these are essentially the tools that I feel like a lot of people are using. These are high priority targets. Boxmolly, it's pretty much just universal. Dex Education, I feel like so many people use this. This is all I hear people usually talking about when they talk about reverse engineering Android applications. IDA Pro, that's a gimme because everyone uses IDA Pro or everyone has it. Someone is always sharing their licenses with other people, all that kind of stuff. And Android Guard, it seems to be very popular. VirusTotal uses it. I think Anubis uses it. There's lots of different applications. So when we're trying to think of how can we break these tools, we just thought, well, let's kick it old school. Let's do just an old jar hack. When people are trying to reverse engineer Java, it's so easy because you can just do a Java decompiler. So if you could break those back in the day, that was really interesting and cool. So I remember trying to unzip something and it would just blow up on me because since jar is just a zip, you can extract it and then you get the files that were originally in there. So if you just hit the file system as the weakness and you try and do something that's over 255 characters, you can prevent someone from actually unzipping it. So maybe we can actually break some tools by making a class that's so goddamn long that it just breaks these things. This required, in the old school days, is basically required, editing the jar inline. A jar doesn't care how long a file is because it's just all contained inside that jar. So we're basically just trying to attack that file system limitation. So how can we port this to a DEX file? I haven't really seen many people talk about this type of stuff, so I got interested in it and I started looking at that Dalvik format and well, how can we make a tool that could do this for us? So basically, you have the class def item. This is the essential structure of it, and the part we're concerned about is actually going to be the class index. And that basically just points into the type item, which has a field called the descriptor index. And basically this points into the string ID item, which is, these is just pointing back and forth to different tables. And this points to a string data offset, which is again in that, that mystical chunk of data called data section. And inside here, we can see that we basically have a string data item, which has, it has a uleb 128 that basically says what's the length of the file. And we want to basically inject our data into here. So how did this work? So basically, we wanted to just append data on the end because the string table always needs to be in order. So if we start messing around and adding weird things, we're gonna have to do more work by reshuffling all that and all the items that actually point to that need to be reshuffled. So we just basically dumped a really long string that's annoying at the end of a class name and just see if we could break it. So we wrote a quick proof of concept tool for this. It was actually really easy to do. And what happens is this is actually a screenshot from O&O editor. And you can see the original class, don't decompile me, build config. And then we added one, why would you go and do something like this? And there's a little story at the end of that, and it kind of got out of control. So what happens? We modify that file, we re-sign the APK, we're going to push it to an emulator. It worked fine. It didn't take the 3 seconds I just described, but it took a while. And basically, we're just going to see, can we break Boxmolly this way? So Boxmolly is actually going to be outputting these files just to your hard drive. So what happens? And as you can see, it just dies on this file class name, and it's a nice long class name. So what were the results? So IDA-Pro works fine. It doesn't actually output any files. It's just using its own internal IDB file. So it just handles this properly. Dex-Jar works too, somewhat. Basically because it's going to process this and just dump it directly into a jar. So as we said, jars don't care what the length of the files are. If you then tried to unzip that jar, you would probably get an error, but it should be fine. You can then open it in JD GUI and it will work fine. So Boxmolly actually handles this pretty well. It'll skip that class only. So if you were hiding something inside that class, this file's not going to be output. You're not going to be able to analyze that if you have some kind of Smolly parsing machine. But it does actually end up processing the rest of the files. So we want to break more things. So what else can we do? Actually, first, why would we care about this long string limit? So it's really easy to detect and it's really easy to work around. Basically, we could submit a patch to Boxmolly that was saying, if it's too long, let me truncate this. There's actually, I believe, JD GUI handles it this way when it tries to process files that way. But if you see something like this might be a really interesting file to look at. It's definitely something you might want to alert on and flag for maybe human analysis. Because if someone's doing this, either they're just really, really bad at Java programming and they went into Eclipse and said let's ignore all these really bad errors that I shouldn't be ignoring, and they've compiled this huge class name, or they're trying to mess with you. So there's a bunch of other interesting things you can do with this. So basically, if something's being dumped to the file system, you can try and attack that person's file system that way. One thing I saw, I had a fresh MacBook install, and so it comes with that awesome case-sensitive file system, which just sucks so bad. And basically, I saw some people doing some obfuscation techniques that was capital I, lowercase I, capital I, lowercase I, and then they'd inverse those. And technically, they're different files, but Boxmolly started overwriting each other, and you're like, where'd these magic files go? I only have 3 classes, and it's referencing like 30. That was actually a fix that Jesus Freak has already committed to Boxmolly a while ago. It'll actually start appending 2, 3 onto those file names. The other interesting thing is you can throw different ASCII characters since they're all considered valid, and that's just going to be a real pain in the ass to work with on the command line. So I just remember growing up and doing some malware analysis, and I always loved it when people tried to mess with the tools. And one of the interesting things was when people would inject bad opcodes. So, the auto analysis of IDA would just blow up or something, or Ollie debug would just start barfing everywhere. So I definitely wanted to try and inject bad opcodes behind dead code that just wouldn't get processed. So the objective was definitely get this on a phone and let it work for a normal user, but at the same time killing all those tools. So the goal, if you can't read Dalvik opcodes, which maybe some of you guys can, if you can, speak to me, I would love to hire you. Basically, you're going to load 0 into the first register, and then we're just going to say, hey, is the first register 0? If it is, jump over the next instructions. So clearly this should never be executed. We threw this in, we injected it in a couple classes, it compiled, we then signed this and we pushed it to the device and it just started working. It was really cool. So I was like, okay, this is awesome. Like, this was a lot easier than I ever anticipated. And then it just sucked. From there, it just went downhill. The Dalvik verifier pretty much just smacked us in the face and said, no, you're a bad person, go away. And so why did this fail? So the Dalvik verifier ends up on execution looking at actual code paths that are going to be gone through and traversed and actually possibly executed. They don't look to see if essentially, that was a bad jump. That should never go through, but it just ignores that and sees, is everything in here okay? So everything in there was not okay. So this was an issue for us. So how can we avoid the verifier? We need to dodge that guy. Basically, we came up with the idea that we want to inject the same opcodes, but into a class that we're not using. So if we aren't using the class, maybe the verifier won't go in there. And this ended up working. It installed fine, and we can actually look at it. So what was happening is it appears that the way that the verifier is working is it's trying to optimize how much work it's doing. And by taking that optimization, it says, you're not using this class file, I don't care, I'm not going to verify that. So this would normally be a file, if you ran ProGuard, that would get stripped out because it's never actually referenced inside the project. So who can we break with this? So Boxmolly dies. They actually just committed a fix for this. He's a machine, he's just always working on this, and I love sending him bugs and he fixes it the next day. But basically, it was dying, it was attempting to go into that dead code, and it would just fail. Dex Education, same issue. We're trying to load it in, and it basically is just, I don't know what this opcode is, go away, please leave me alone. Android Guard, same thing. He actually did a really good job of handling the opcodes that he didn't know. There was actually just a few, I think there was like 3 opcodes that he happened to miss, probably coding late at night, something like that. But he basically did anticipate someone to try and do this, but he just missed a few opcodes, so I was able to just use that specific opcode, and it broke his tool as well. IDA, well, we kind of expected IDA to handle this. It's a tool that's been around a while. It's had these attacks performed against it. So basically, you can see it's just jumping around that, and it's like, I don't know what this opcode is. I'm just going to label it unused. There's this really interesting tool. It's an academic tool. I don't know many people who actually use it, but a friend of mine was just like, please run it against this tool. I want to see what happens. They use half the Dalvik headers anyway, right from AOSP, so it should work on everything. And it didn't. It just completely died, and then you could basically, cook a bowl of soup on your laptop because it just sits there spinning and the core just goes to 100%. So IDA Pro is the only one who handled this properly. They're the guys that get paid. They get to do this daily, and they're not doing this as a side project. So that's not really that big of a surprise. They also have lots of experience doing this kind of thing. So how can we develop our tools better? We got to predict this. This is an awesome edge case that people should be thinking about when they're developing tools that might be used to analyze malicious applications or just normal applications. Someone's probably going to mess with you at some time. And this is a really easy thing, and this is a very not complex idea to try and implement. So we should always just be thinking about that. So this is a good thing for automated analysis, because if you have your own tool chain and you're looking at things and or you're using any of the other tools that have already been patched, this is an awesome thing to look for. If someone's using illegal opcodes, they're probably doing something really weird. So you can treat it as a no-op, but at the same time, it's just something that you should probably be looking at. Maybe you found something where someone's doing some really crazy things, but this is just a great indicator that you should really look at this file. So once we injected illegal opcodes and the verifier barfed, we were thinking, okay, well, what's the next step? What if we inject real good code, or somewhat good code? We're going to try and reference an object that doesn't actually exist. So as we said, there was the string table. So if you're loading a string and you do like a const string load, you're saying, I want string from position 1. Well, if you only have 10 strings, what happens if we start referencing something that's string 12, 14, 15? This should die. Most tools should handle this, but we just wanted to see what would happen. So Boxmolly barfs all over the place. It's just basically like, I do not know where to go. I'm indexing and I'm looking inside my array, and my array is not that big. So Boxmolly, check. Dex Education, same thing. It's just saying, I don't know what you're referencing and why you're referencing that. Please stop hurting me. Android Guard handles it a little bit better, mainly because the way I've used it, you're going to attempt to decompile that specific class, but at the same time, that class will then make Android Guard die. And again, back to dead, it basically sits there, it's looking for it, and it's looking for it, and it'll do this probably until you reboot your machine or kill the process. IDA Pro did something really interesting. It's not bad what they did, but they just basically said, I have no idea where you're pointing at. I'm going to point to 0. So it was an interesting thing on IDA's part. So this really isn't hard to fix either. You can basically just say, all right, well, I know what my string table's like. I know what my method table's like. I know what the bounds are. If someone asks for something outside of that, I probably shouldn't let them do that. And if that index that you're asking for is bigger than that table size, let's alert on this. This is definitely another thing that someone's trying to mess with you, or your tool is horribly broken. So you should definitely take a look at this. So, as I said, a lot of people use Dexajar. I feel like I talk to a lot of people and they're just like, that's my go-to. Dexajar is my homie. Like we hang out all the time and we just play stuff. It's cool. So I just wanted to break that tool just to try and dispel a myth that you can just use all of your own Java tools. I really think it's necessary that you should be looking at Dalvik specific tools. While this is one, a lot of people are just using this as a segue to then use just Java analysis tools. So my limited understanding of what JAD and JDGUI does is it's essentially looking for patterns that it's seen so that it can see that, okay, so the Java C compiler basically took this and this is a while loop, this is a for loop. So this is why you get those actually decently readable things. When you're using the Dalvik compiler and then Dexajar translates that to literal opcodes, it's not actually changing those patterns. And since the Dalvik compiler uses different patterns for mobile uses, it's going to be a pattern that most of the time JAD or JDGUI doesn't actually know. So this results in really funky looking code where, oh, there's the beginning of my function and then there's a return and then there's all the rest of the stuff. And clearly that's not valid Java and that's really bad to look at. So you end up seeing a lot of stuff like this too, where if they just don't understand what's going on, or you're doing things that are legal in Dalvik world but not in Java world, you just get this awesome window that just doesn't help at all. So one thing that we just looked at, it was really easy to figure out, well, how can I get like JDGUI to not work well? JAD actually handles this pretty well, but basically throw a couple exceptions. The way the exceptions are then compiled down to the Dalvik level makes it so that a Java decompiler gets a little bit confused by it. Another really interesting example that I found is actually in the Boxmolly repository. Jesus Freak did this one, and I just completely stole it. Essentially, this is a recursive try-catch function. So I've circled the first try block, and that's pointing to the catch block. And inside the catch block is actually the second try block, which is pointing to its own catch block. So what's going to happen is you're going to throw an exception and you're going to catch, throw, catch, throw, catch, throw, and it's this infinite weirdness that is just not going to work well if you ever execute this. I'm not 100% sure if you could ever actually write this in Java code. You could probably do something with a recursive function, but it's not going to end up being the same. But this is valid Dalvik code. So we're taking a look at this, and like I said, you're not going to want to actually execute this, but this is going to be valid code to have in one of your classes. So if you did like a dead code segment, this would be a great one to put in there. So the interesting thing is you have JAD that looks at this, and it's just like, hey, you threw some exceptions, and that's it. I'm just going to stop processing after that. JDGUI is just chugging away there, and it's just no good output. We got IDA, and what's interesting is it sees the exceptions. It's not actually going to connect those with any control flow, so it's going to be pretty annoying to look at. And then actually we can see that it's ignored our other opcodes. So you're going to have to go in there and manually actually tell it, like, start looking at these opcodes and start processing this. If you've used IDA for more than a while, you probably know the hotkey to fix this, but it's still a little annoying. So this is going to actually be a lot harder to detect automatically. You're going to have to do something like pattern matching or some sort like that. Boxmolly works fine on this, so if you had like a Boxmolly parsing engine, it would work fine. But again, if you're using those actual Java decompilers, this might really confuse the heck out of it. So earlier we saw in the link lock section that Boxmolly died just because of something simple that hasn't been implemented yet. So are there any other quick wins like that? And we basically saw this just looking through the header. If header size isn't what I expect, I'm going to barf. So basically, we're going to just do a header size attack and see what we can do. So if we're looking at the Dex header, We basically have, the magic. We have a couple checksums and signatures that are used for verification to make sure we haven't modified our file. The header size, an Indian tag, what is this? Is it reverse Indian, normal Indian? And then we have that actual section that was used for the link lock. And then these are all the offsets again for each other section that's in there. So since it's always expected to have 112 bytes in there, let's just increase it. Let's increase it by 4 bytes. So the concept is basically, let's just increase that, and then we're going to have extra junk in there, put nothing in there, maybe something, who knows. So it should be really easy to implement. Change one field from 112 to 116, see how that works. And basically we're going to fix all the offsets after that. And the offsets should just be the ones in the headers, hopefully. Completely wrong. It was a really bad assumption, and it ended up creating a lot more work. Basically, this is when my proof of concept went from about 100 lines and it ballooned up to, I don't know, like 2,000, 1,000 lines. Because essentially, everything is not a relative offset, which I was hoping it was going to be. It is an offset from the beginning of the file. So if you move things 2 bytes, every single offset in the dalvik file is going to have to be offset by those 2 bytes. Otherwise, things just go really funky and they're going to be pointing to wrong places, wrong sections, all that kind of stuff. So after many, many hours later and lots of caffeine, basically we end up having, this is what the dalvik header looks like. So in the red, that should be 70, but we've increased that. And then in the blue, you can see that we just have some empty bytes, just zeros, didn't really care what we put in there. And then we see we're running this through Boxmolly and it dies on us. And it basically tells you why. It's just not what I expect, so I don't know what's going on. So great, that's really easy to fix, but it probably took longer to implement than it will be to fix. It's basically, instead of throwing runtime exception, system out runtime exception was almost happening, but we're not going to do that anymore. But what are the cool things that we could do with this? We could hide data in there. And this data is actually going to be mapped into memory. So if we can expand that header, we could do probably a lot of cool things. I mean, just think of the jokes I should probably have on this slide, like, yo dog, Dex inside of a Dex, or something like that, but that's just too much work. So the next concept that we had, and my my coworker aptly named this Dexception, because basically we're going to take the header, we're going to increase it a lot, and then we're going to slam a Dex file at the bottom of the header. So basically we're going to have a Dex file, and then we're going to have a Dex file inside of it. So this was actually really easy to implement once we had all the file format shifting and whatnot. So we basically wrote a quick Android application, which due to the awesomeness that is Android, we can actually access private methods and tell them that they're no longer private and start using them. In Ice Cream Sandwich, I believe it's Ice Cream Sandwich, they started having this, this awesome function which basically lets us load in a Dex file from a byte array. So I quickly implemented, I'm just going to load this from my own resource file, but you could do this from reading from memory, you could do this from reading from the dalvik cache, anywhere you'd like, anywhere you have that Dex file, and basically just reflectively call this function, and you're going to get a Dex file, which is just a Java object. And you can start referencing that the same way you would reference if you loaded an extra jar in Java. So cool, we just basically created the first packer/encryptor. And this is what the output looks like. This is O&O editor. So again, I stress that you should always use this tool if you ever encounter anything like this. No, I'm not getting paid to say that either. But basically, you can see the Dex header is not what we expect. That is not OX70. It's a pretty big header, and you can see I did this really lame XOR with D1 because you just see D1 in there all the time. But basically, we just made a little weak encryptor. So the results from this are, I think, pretty cool. So you're going to break Boxmolly until they fix that, which the fix is, I believe, imminent. But you're basically going to slow down a lot of automated tools, because this is going to be something that, if I XOR it with this or that, it's going to change how you're going to have to unpack it. What happens if I didn't put a Dex file in there? You could put an APK file in there. You could put pretty much anything you want. You could just put some images, anything. It doesn't matter. But this way, all these tools are going to actually follow the rules of the dalvik format, and they're just going to skip over that data. So nobody's really going to die on that anymore, but the verifier is not going to die on that, and you're going to be able to load this on an actual device as well. So, like I said, if it's encrypted, that's going to make it a little bit harder for someone. This is going to be definitely like a manual process. You could, like I said, you could zip it up, zip a Dex. Now we have, a packer for real. And then you could even throw native code in there. This is the possibilities are essentially endless at this point. So the nice part of this hiding technique is it's super easy to detect. If it's not what we expect, alert. Someone is clearly doing something to mess with people, or your system, or your analysis, or they're just doing cool stuff and you should just check it out because they're probably doing something really cool. You know, the reason the header file lets you do this is for future compatibility. So if you see this, you might also have just discovered, you know, I don't know, the first keyline binary or something like that, and that'd be kind of cool to look at. Anyway. So this is one that I actually did not end up implementing. So this is completely open to interpretation. Basically, there's an Indian tag, and it's always set the same way. And if you look at the way all the tools are actually, all the open source tools at least, that are parsing these files, what happens if you do reverse endian? Well, they all barf. And nobody's actually done this yet. I don't really want to do that because that's a lot of work for very little gain. But basically, you could break all the tools that way. And when this is loaded onto a device that doesn't support reverse endian, Android is just basically going to automatically swap all those bytes back and map it to an ODEX file, which will just basically run properly on your device. So now we're going to dip into anti-emulators. Since I had gotten this talk accepted, there's been a bunch of interesting things about Bouncer and whatnot, which is one of the emulators people want to get by. So I didn't want to go too in-depth over that. I think people have covered this subject pretty well. It's basically, you know, an emulator is the QEMU, so there's a lot of different ways to detect that. But just looking at some Android-specific things, you know, I've seen a couple people, TaintDroid basically is one of the big projects that runs dynamic analysis and tries to do taint tracking and whatnot. And their recommendations were, you know, set an Android ID, change your IMEI, change your phone number. So that way when people are requesting these, that they're just not going to throw null out there, and it's clear that those would be emulators. But I haven't seen anything other than that on how can I make my emulator better. So basically, there's this awesome tool called getProp. It's basically get a system property. And then what we see when we do a getProp is, you know, we see QEMU settings and whatnot. We see that the radio driver is emulated. It's not an actual full. Radio driver. And then we also see different things like QEMU fake camera. Like, oh, okay, well that's probably a good indication that you're not on a real device because there's QEMU settings all everywhere. You know, and it's just take your pick. There's so many things out there that if someone hasn't actually tried to make it look like a real device, there's just so many interesting things that you can just pick up on. And what makes it easier to avoid emulators is you can also do the inverse. You can basically just say, I don't want to look to see if this is an emulator. I want to see if this is a real device. So most devices that people use are running Google software. So like Google proprietary things for the Google Experience devices. So if we can look at, you know, RO URL legal, that's one that's used by actual Google Android applications, and it's usually set there on a real device. So if you look for something like this or a specific fingerprint or a build ID, you can then usually determine that, you know, they could fake this, but at the same time, a lot of people haven't gone through the effort to actually proofing their emulators out. So how do you use getProp though? Usually most people just do ADB, shell, and then they use getProp. And this is again where that awesome reflection comes to the wind. It's a private method, but it's still there. So you can basically just say, I want this, you know, system properties get, and then just let me access this, and there you go. You have a really, really easy way to detect emulators. So this is pretty easy to flag statically. It's again, you know, you're going to look for a reflective method. Again, I don't think that that's the best thing. You shouldn't just say, hey, if anything comes in with reflection, we're just going to flag it. That's going to lead into lots of false positives. You could do a couple interesting things. I mean, you could basically go the TaintDroid route where you basically you taint the function and you're going to actually intercept it, and then you could change the output of it. You could actually do an LD preload on this. There's actually a nice little example of an LD preload hook written by a guy in France, and it was actually pretty cool to look at. So, you know, nobody's fallen asleep yet that I can tell, but hopefully you actually want to go and play with the tool. So I created this. It's going to be under GPL. It'll be on my GitHub page soon. I don't really want to push it on this network, so like many of the presenters, as soon as I get to a better network, I'll push my slides and both this. Be wary about the code. It was a proof of concept that I tried to do as fast as humanly possible. I also did it kind of like a Hackternoon project, and I wanted to improve some Ruby skills. I probably just did some very detrimental things to my Ruby skills because heavy file manipulation is kind of weird. If any of you guys are awesome at Ruby, you might hate me for looking at that code. But so what have we actually learned? Parsing DEX files is definitely something that I feel like if you're looking in the Android space, you should at least wrap your head around this. Don't rely on all the tools that are out there. You're not paying those people to improve the tools. So we got to help them. We got to improve the tools. We got to understand the file format. There's definitely some really interesting things that people can start doing. Take the lessons learned from PC malware. People are going to abuse this stuff. So we need to be able to anticipate this and actually start looking at it before those bad guys do. And then just on a little podium, John Lemmermeyer, I just murdered his name, but he made an awesome template that I have a bunch of screenshots for. O&O editor, again, they're not paying me, but maybe they should. And then also just on the soapbox again, just because something sends SMS, please stop writing papers that all things that do that are bad. You don't need machine learning to tell anyone that SMSs are bad, but let's step up the actual research and let's look at things a little bit more. Like let's look at the context of things and whatnot, and let's just don't be lazy. And again, have fun, break stuff. Let's push those boundaries and let's just get there before the bad guys do. So thank you. And if you guys have any questions, I can take them now or later. Sure, you can talk to me later then.
I've got one question for you.
Sure.
For the reverse Indian, you said you didn't actually try it, but then you said it would work on the device. So how do you know?
Right. So if you look, we got AOSP, so we can look at all the code, and the way all the code is actually set up is it goes and it looks at that tag, and then it basically says if this isn't Indian, swap every single other byte. And while I haven't seen that actually in use, I believe that they wouldn't push that horrible of code that, it's all there. You can take a look at it. Like I said, I haven't tried it, but it should actually swap all the bytes. Anyone else?
So just curious about the zip file.
Mm-hmm.
I'm not sure about the zip file format. Is it really easy to produce zip files like that, which will sort with something and produce it?
So I believe the question was essentially that the zip file, will the zip files actually accept something that have the extra bytes XORed in it? All right, I'll give you a second.
Is it really easy to produce zip files in the way you described, like you XORed it with something and you had both those zip files, like the XORed file and the original file, both were valid files and both were unzipping to different contents? Is it really easy to do that?
So I'm not 100% sure. They definitely did it. I don't know how hard it would be. I don't know the zip file format too well. It looks like what they did is they basically put it into some padding, which would normally be there. And then if we look at that slide again, basically you see that when you unzip it, it was basically complaining that there's something there, but it's skipping it. So I'm not sure how easy that is to do, but it's definitely a viable target to do. And that sample is actually on Contagio, so if you're interested in looking at that, it's all there and whatnot. I'd love to find out if that was easy or hard to do, though. Anything else? All right, thank you guys.